Okay, my dear children, now let us go for the next concept based upon the same acceleration and motion under gravity. Okay, now there is a freely falling body. There is a freely falling body or a freely falling body passes through 2 points A and B. Passes through 2 points A and B in a time interval T1 and T2 from the start. Let us do like that. What I am saying is that let us consider a freely falling body which is passing through 2 different points A and B. Okay, in a time interval T1 and T2 from the beginning, in the sense from the start of its motion. In such case, then what is the distance moved by the freely falling body from point A to point B? Point A to point B. Okay. So, let me draw. So, let me assume this is point A and let me assume this is point B. So, what I am saying is that a freely falling body passes through 2 points A and B in a time interval T1 and T2 from the start. T1 and T2 from the start. So look, my dear children, what I am saying is that there is a freely falling body. So what is the symbol for a freely falling body? So like this, I say that this is one body. Okay. Now this freely falling body, freely falling in the sense I have to show it by dotted lines. This shows that initial velocity is 0. Initial velocity of this body is 0. Since it is coming down, acceleration is equal to plus g. Since it is coming down, acceleration is equal to plus g. Okay. So what is happening? Passes through 2 points A and B in a time interval T1 and T2. So up to point A, the time taken is T1, and up to point B, the time taken is T2. From where? That is what is important. From the start. Okay. So this is what is starting position, right? So this is what is starting position. So from the start up to point A, the time taken is T1. So up to point A, right? The time taken is T1. And then T2, again from the start only, not from point A. Again from the starting itself, I will say taking the time as T2. Okay. So this is start, right? Up to point B, I am considering the time taken is T2 like this. Okay, my dear children. So from the beginning onwards, the time taken up to point A is T1, and similarly from the beginning onwards, up to point B, the time taken is T2. Like that, I am taking 2 different time intervals. Now my question is that what is the distance travelled by the body from point A to B? What is the distance travelled by the body from point A to B? Let us consider. From the start, then find the distance travelled by the body from point A to B. So this is what the question. It means that our interest is that we have to calculate this distance from A to B. So distance symbol is S. Since it is starting at A and ending at B, let me write SAB. So this is what we have to find out. Okay, my dear children? Is it clear? So let us assume the starting point as what? Let me say O. O is the starting point. Okay. So how to calculate this? It was very clear that the total distance from O to B is equal to O to A plus A to B. Very clear, no? The total distance we are taking it as O to B, which can be written as sum of O to A, OA plus AB. Like this we could write. So the total distance, what we could write is that from O to B can be written as distance traveled from O to A plus distance traveled from A to B. Firstly, you could write like this. Okay, our interest upon is that we have to calculate the distance from A to B. We'll calculate that, no problem. Now, we have studied earlier the equations of motion. The distance formula is given as S is equal to ut plus half at square. Whereas for a freely falling body, we have written it as S is equal to half gt square. For a freely falling body, we have written it as S is equal to half gt square, right? So, since for a freely falling body, we have written it as S is equal to half gt square. The same thing I'll apply here with the minor changes. So, distance from O to B, okay, half g t square. But here the time is from O to B. Let me write O to B. Whereas from O to A also same equation, that is since it is a free falling body. Whereas we have to consider the time taken from O to A. Plus we have to calculate this AB. That is distance from point A to B. Now see, my dear children, the time taken from O to B. So this is point 2 and this is point B. We are assuming the time taken from O to B as T2. So T2 is nothing but time taken from O to B. So what I write here is that half G T2 square is equal to, right? Here half G and time from O to A. O to A, the time is T1. So it is T1 square plus SAV. This is the value, right? If I move this side, now this positive value will become negative. That is half G T2 square minus half G T1 square is equal to distance from A to B. So half G is taken as common. Now we can write it as T2 square minus T1 square. This is what is the distance covered from point A to B. This is what is our question. Then find the distance travelled by the body from point A to B. So the distance travelled by the body from point A to B is written as half G T2 square minus T1 square. I hope you understood this, right? So also again, if you want, I'll explain you. So in this given diagram, what I am saying is that a body has been freely falling. Since it is freely falling, we will have to say that its initial velocity is equal to 0. As told earlier, see, this is what is freely falling or dropped. I am not applying any kind of velocity. So its initial velocity is 0. When it is coming down towards the center of the earth, what we have to say is that the acceleration is nothing but due to gravity, right? So A is taken as G. While coming down, it is plus G. Understood now? Now, in its journey, as per the given question, we are considering it as from point O to A, the time taken is T1. Whereas from point O to B, the time taken is T2. Like this, we have classified 2 different times. Okay. But one major part that we know here is that the overall distance is equal to sum of the distance. That everybody knows that. Okay. If I say that you have started a journey from your house to your school. In the middle, there is a shop. So what happens is that the overall distance from your house to shop is house to school can be divided as sum of the distance from your house to shop plus shop to school. Similarly, this point is your house and this point is your school. In the middle, there is a shop. So overall distance can be taken as sum of these 2 distances. That is, overall distance from O to B can be taken as O to A plus A to B. That is what I have taken here. Where S stands for distance. So as for the free falling body concept, the S is given as half gt square. The same thing I have substituted. The only minor change what I have done is that simply I am putting suffix. I am telling you from the beginning onwards, the suffix is very important. So this we are writing it as from O to B. So here also the time is from O to B. And this I am taking it as O to A. So the time is also from O to A. As I mentioned earlier, from O to B the time is T2 and from O to A the time is T1. Okay. So O to A the time is T1. So this is the only change I have done. So by moving it this side and left hand side, we can write it as a minus. By taking common, we will get out the final distance from A to B. That is half G T2 square minus T1 square. Understood? Have a clear look of this. you can understand it better. So it was like this. A freely falling body now again passes through two points, A and B. A and B at a distance of H1 and H2 from the start, means from the beginning onwards. Then find the time interval between point A and B. This is what the question. Or then find the time taken by the body to move from point A to B. You can also say like that. So then the find interval between point A and B. It means I need to find out the time taken by the body to move from A to B. This is what I have to find out. Okay, my dear children. So as per the given question, when the freely falling body passes through 2 points, one is point A. So when it is moving up to point A, its distance is taken as H1. So up to point A, I have to take this distance as H1. Whereas up to point B, we have to take its distance as H2. So this is H2. So this is what is given in the question. Okay. So if you look at the diagram carefully, from O to A, its distance is H1. From O to B, its distance is H2. Like this I could write. Okay. Now, my interest is that I have to find the time taken by the body to move from A to B. So that is interval. Interval in the sense middle of A and B. So what do you know about the time? How did you find out the relation of the time? So this one we have discussed in the equations of motion, that is for a freely falling body, S is equal to half g t square. Okay, from that only I will take it. Understood? So initially we have discussed that for freely falling body, for a freely falling body, we have taken it as S is equal to half g t square. So S stands for distance, isn't it? So here the distance from point O to A. So let me write O to A, and this is also O to A. So distance from point O to A is H1 is equal to half g, whereas time from O to A is taken as, let me take it T1. Okay. So time from O to A, or let me leave T O to A only. So here if you observe, 2h1 by g is equal to time taken from O to A whole square. Now I don't want this whole square. Why? Because I just want the time, not square of the time. So I have to push this 2 to the other side. If 2 is moving to other side, it will be to the power of 1 by 2. Okay. It will become this value to the power of 1 by 2. That is root. So root of 2h1 by g is equal to time taken from O to A. Like that we could write. Okay, my dear children. The same thing happened for next case, that is O to B. So similarly, right, distance from O to B is equal to half g time from O to B whole square. So again this distance from O to B is taken as H2 as per the diagram. Okay, that is half g O to B whole square. For distance you can write either H or S, that is overish, it's not a matter. Okay. So by solving this again same fashion, what do you get here? This g by 2 will be moved towards the left hand side, and you could write it as 2h2 by g is equal to TOB, where one more thing is that you have to apply root. Like this you'll get. Okay. So same, both are same applications. The only thing is that T1 and T2, or TOA, TOA and TOB. Like that I have taken. Okay. Now, so I could say that during its journey from point O to B, that is equal to O to A plus A to B, like that I could write. So, the total time taken from O to B in its journey can be written as the time taken from O to A plus the time taken from A to B. So, like this I could write. My interest upon is that I have to calculate the time interval between A and B. So, what is that? This one. Time from A to B. Okay, my dear children. Now let me substitute whatever I got here. So TO is written as root of 2h1 by g. So this part I got it as root of 2h1 by g. Whereas this part I got it as root over 2h2 by g. Plus, and this part is time from A to B. So when I move this towards the LHS side, what I'm going to get is that root 2h2 by g minus root 2h1 by g is equal to time taken from A to B. This is the very good, right? Here we could take 2 root of 2 by g as common, because here you got 2 by g and here also you got 2 by g. So what I could do, and root is there here. So root of 2 by g can be taken as common. That is root of 2 by g. This is nothing but I could write it as root h2 minus of root of 2 by g into root h1. If I write like this, you will understand better. So now this part and this part can be taken as common. So that is root of 2 by g is taken as common. So the answer is root h2 minus root h1. Okay. Root of h2 minus h1, which is equal to time taken from A to B. Time taken from it. That is, whenever a body is traveling here from point O to point B, if you are interested to find out the time taken from point A to B, then this is the way we have to do it. So here, as per the given question, it is a freely falling body. So that is the reason why we have to say that its initial velocity is equal to 0. Now, when it's passing the 2 points A and B, we have assumed that distance is h1 and h2. So from the beginning up to point A, the distance is h1, and from the beginning up to the point B, the distance is h2. So all these things are given in the question, right? The only thing what he is asking is that find out the time taken from A to B, that is time interval from A to B. As per the sources I am having, so what are the sources? Equations of motion for a freely falling body. If distance and time both are correlated, so I have to use S is equal to half g t square. S is equal to half g t square. So that is the reason why I have taken S is equal to half g t square, from which I found out what is the time taken from O to A and what is the time taken from O to B. So see, two different cases I have taken. Time taken from O to A and time taken from O to B. So the two things I have substituted here from the common fact that in its journey from O to B, time taken from O to B is equal to time taken from O to A plus A to B. Time taken from O to A plus time taken from A to B. So whatever the answers I got, simply I substitute here and final answer I got like this. So whenever you are interested to find out the time taken between the 2 points, then we have to apply this analysis. Okay, my dear children? Have a close look at this. Okay? Okay, my dear children, next we will go for the next concept. Okay? Suppose you are having a stone. Okay? Now we are throwing it into a well. There is a well, you are throwing a stone like that. But you know the depth of the well. Let me assume the depth of the well is h. After some time, you could hear the sound when the stone meets the water inside the well. Okay? You could hear a sound. We call that sound as sound of splash. Clear na? So my question is that once you throw the stone, no doubt you will hear the sound. My question is that what is the time taken for that sound of splash? It means what is the time taken for the sound to reach your eye, to reach your ear? Clear? So how to calculate that? Once again I am repeating, my dear children, you are having a well beside your house. Let us assume the depth of the well is h, small h. So what are you doing? You are throwing a stone. Not only stone, anything, any object you can throw. So after some time you will hear the sound, no? Right? So what is the time interval, or what is the time taken for the sound of splash? Sound of splash in the sense, sound that is heard by you. This is what is the concept. So now how we will do that? A stone is thrown into a well of depth h. A stone is thrown into a well of depth h. It means now I have to draw the well like this. Whose depth means depth of the water. So this one I am taking it as h. Okay. Well of depth h. And a sound of splash. Sound of splash is heard after t seconds. So this is what is our concept. So you're able to hear the sound of splash after t seconds. Now, what is the time? How you will find out that? Is it clear? How you will find out? So I'm saying that a stone is thrown. So this is a stone which has been thrown like this. Simply for releasing it. Or instead of saying thrown, let me say a stone is dropped. So that you'll understand better grammatically. So dropped in the sense, as I told you earlier, its initial velocity is equal to 0. So the initial velocity of the stone is 0. Is it clear? Now, in this case, the stone is coming and dropping here. So it will take some time. Let this time be t1. Let this time be t1. So once it hits the water, what happens? A sound is heard by you. Again, the sound is heard by you. Heard by you. Let this time be t2. So you have to calculate two different times. The first thing is time taken by the stone to reach a well of depth h. Right? So first one. Time taken by the stone to reach well of depth h. So how you calculate that time? I say that it is equal to simply root of 2h by g. But you will be having a doubt. How I got that? You will be having a doubt, yes or no? So when I am saying it is dropped, it means that it comes under the concept of a freely falling body. So for a freely falling body, we have studied that s is equal to half g t square. Here distance s is nothing but you have taken it as h. So h is equal to half g t square. So it is 2h by g is equal to t square. So therefore t equal to root over 2h by g. Understand? No? So from this I got the time as root of 2h by g. So the same thing I have done here. So initially the time taken by the stone to reach a well of depth h is given by root of 2h by g. That is t1. So what is the next case? Okay. Stone is coming and falling out of the water. Now you could hear some sound. So let the time taken to hear the sound is t2. Let us assume that the time taken to hear the sound is t2. Time taken to hear the sound is taken as t2. So what is the formula for that one? You know that speed is equal to distance by time. From that, can you write that time is equal to distance by speed? Time equal to distance by speed. Repeating, my dear. You people know that speed is equal to distance by time taken. Here speed of sound I will write. The symbol it is V stands for speed. Suffix sound which indicates that it is speed of a sound, which is equal to distance travelled is nothing but h only. Let us ignore this small gap. By time taken. Distance by time. So let this time here it is, we assume that t2. So from this, okay, I could just rearrange it and I could write t2 is equal to h by v sound. Here t2 stands for time taken for the sound to hear. Clear? So which is given by t2 is equal to distance by speed. Speed of what? Speed of sound. So like this you could write t2. Now, what we are interested to find is that sound of splash means complete time we have to write. Okay. Time, we have to say total time taken for the sound of splash. Total time taken for the sound of splash, which is given by sum of these two times T1 and T2. So that is T is equal to, here T1 is nothing but root of 2h by g, okay, whereas T2 is nothing but h by speed of a sound. So this is what is the total time taken for the sound of a splash. Is it clear, my dear children? Observe carefully. I am repeating for you once again. As for the given question, a stone is dropped. So this is a stone which has been dropped. So drop, the name itself implies that it comes under the concept of a freely falling body whose initial velocity is equal to 0. Okay. So it has been dropped. Now I assume that the time taken for the stone to reach water inside a well is T1. So time taken by the stone to reach water or a well which is of depth h is nothing but root of 2h by g. I told you how we got this 2h by g. As for the freely falling body application, okay, you know that s is equal to half gt square. S is the distance. Here distance s is replaced by h. So from this you got the time. Okay. So this is the time taken for the stone to reach a well of a depth h. So that is what I got here. So once it reaches the well, what happens? It hits the water and we could hear the sound back. Again, the time taken to hear the sound back is nothing but T2. Time taken to hear the sound back is nothing but T2. So how to find out that T2? We know clearly the formula, the relation between the speed of a sound as well as the time. Nothing but speed is equal to distance per time. Here the distance nothing but this water only, h. Okay. Of course, you may be considering the small distance. What I am saying is that just regulate this because very small. Clear? Now, as for this concept, speed is equal to distance by time and time is equal to distance by speed. So distance here it is h. So here the time taken is nothing but distance by speed. So dt is equal to distance nothing but well distance h, and speed is nothing but speed of a sound. So v suffix sound stands for speed of a sound. So this time I have calculated. Now my interest upon is that I have to calculate the total time taken. What is the total time taken? Nothing but sound of splash. Total time taken for the sound of splash. Nothing but sum of these two times T1 and T2. So T1 plus T2 is written as root of 2h by g plus h by speed of a sound. This is very important application, my dear children. You will be getting this question directly in your entrance examinations. Very important. Have a note of this one. Clearly observe each and every point. Okay. So, okay, my dear children. Next, we'll go for the next concept. Okay. So, there is a stone with us. Normally, we do it. We are having a stone, something with us. Suppose we are standing on a bridge. Okay. So, what we do? We used to throw the stones into the river. Is it clear? So, you are having two of your friends are standing on the bridge. The first one simply drops the stone. No doubt, after some time, it will reach the water. It will fall into the water. So, I will say that it is reaching the water. The other person who is standing beside you, maybe your friend or relative, what it may be, he observes you and starts throwing other stone. So, observe the difference between these two. In the first case, you are simply leaving it. You are dropping it or releasing it, or it is freely falling. So, that is different concept. In the next case, what is happening? Your friend or your neighbor, what it may be, by observing you, what he is doing? He takes the stone and throws it, okay, forcibly, with some good velocity, means high velocity. So, what the difference you observe is that since it's throwing with high velocity, we observe that both of your stones are reaching at a time, simultaneously reaching the water. Though you have thrown it before, or sometime before, and he has thrown the stone after x seconds or after t seconds, what it may be, both of your stones are reaching the water at the same time. This is what you are observing. So, how you will understand this concept? Now, let me write this. A stone is released from a person standing on a bridge. Okay. And after some time, his friend who is standing beside him projects other stone with some velocity so that both of them reaches water or river simultaneously. Once again repeating, a stone is released from a person standing on a bridge. Okay, and after some time, his friend who is standing beside him projects other stone with some velocity. Okay, so that both of them reaches river simultaneously. Here, let me say that, and after some time, I am saying no. After some time is let it be x seconds, or you can say after x seconds directly. After x seconds, clear? His friend who is standing beside him projects other stone with some velocity so that both of them reaches water or river simultaneously. So how we will understand this concept? That is what the question. So let me say this is bridge. This is bridge. Okay? Under that there is water. So he is the first person, 1, and his friend is standing over here, 2. Now, what he is saying is that a stone is released. Released in the sense you could say dropped. Dropped in the sense other name is freely falling. So like this you have to understand. Okay. So now initially one stone has been released. So released in the sense dot lines. So that initial velocity of this first stone is 0, 1, first stone. Since it is coming down, okay, since it is coming down, acceleration is plus g. Let it be a1. And after x seconds, second stone has been projected. Projected in the sense, what is the difference between freely falling and projecting? If I am throwing like this, forcefully, so you have to say it is projected with some velocity. I am applying some velocity. Okay. So in this case, forcefully you are throwing that. So there is some velocity. u2. Let me assume it as u. Since it is coming down, it is plus g only. No doubt in that. But what is saying after x seconds? Okay. You people think that initially if I assume the time taken is t seconds, then for second case, you people feel that after x seconds means it is t plus x. That is the way you feel. I know that. So for the first case, if I say that t is the time seconds to reach water, then for the second case, what you feel is that since it is after the x seconds, you calculate as t plus x. But it's not like that. So now just imagine. Okay. Understand the question, read the question again and again, you understand better. What the important task is that both of them are reaching simultaneously. So this is what is the important twist I have to say. If both of them reaching simultaneously means what does it mean? If the first stone is taking some 10 seconds to reach water, the second stone is taking very much less time so that both are reaching simultaneously. Both are reaching simultaneously. It means that the first one is taking more time and the second one is taking very less time. Why? Because the second one is thrown with some velocity, positioned with some velocity. It means it is coming the highest velocity. So that it will take less time. It has to take less time. Why? Because both are meeting simultaneously. It is possible only when the first one is taking more time, moving with less velocity. And the second one is taking very less time, which is moving with high velocity. So in these two cases, what you understand is that the first one is taking more time and second one is taking less time, repeating the same thing. second one is taking less time. So less. What do you mean with that less time? It means if I assume that the first one is taking t seconds, then the second one has to take less time. How much less? After x seconds means the second one after x seconds means in the sense if first one is taking t seconds, then the second one has to take t minus x. T minus x. Because I am saying it is less time now. Why less time? Because this is the reason. Both of them are reaching simultaneously. It can reach simultaneously only when it is moving with high velocity and less time, the second body. So less time in the sense, initial time minus of some time. What is that minus of some time? X seconds. Okay? Since I mentioned here x seconds, I have to take minus. Now, from this point, what I have written here, since both of them are reaching simultaneously, the same thing I write here. Since both the stones are reaching simultaneously, it means the distance travelled by the first stone must be equal to distance travelled by the second stone. So that is the meaning of both of them are crossing or meeting or reaching simultaneously. So if first one freely falling, so what I have to say, half g t square. Where is ut? Okay, let me write ut. But the problem is that when it is dropped or released or freely falling, as I mentioned earlier that in these cases the initial velocity is equal to 0. So that is what I have shown here. So even if I write here, there is no use because it is 0. So this is cancelled. So remaining part is half g t square. Okay. Now for the second stone, velocity is given. Because you are projecting it. You are projecting it some velocity. So you have to consider that. So here also the same formula. ut plus half g t square. Since it is second one, let me write 2. Since it is first one, here time t1 and here time t2. Like this I have to write. Okay. So here u2 is what? U. No doubt in that. Okay. Now, coming to the time. If I assume that the first one takes time t, then what about the second one, my dear? So as I mentioned earlier, the second one has to take more time or less time? No doubt, it has to take less time. Then only it can reach simultaneously along with the first one. If the first one is taking t times, okay, t seconds, then since second one has been thrown after some time, means some time has been wasted. Even though it is wasted, it is reaching simultaneously. It means that it has to take less time, that is t1 minus x seconds is nothing but t2. Okay, so what is t1 here? T1 is nothing but t. So t2 is equal to t1 is t minus x. This is the way we have to write. Okay. So now the same thing I am writing here. So where t2 is nothing but t minus x plus half g into t minus x whole square. So this is the way we have to write. Is it clear, children? So the only task here what you have to observe is that since both of them are reaching simultaneously, even though second one has been projected late, it says that the second one is taking less time. Less in the sense we have to subtract. If first one is taking some 10 seconds, second one has to take either 4 seconds or 5 seconds but not 10. So in order to get 4 or 5, you have to subtract some time. So what is that some time? After x seconds. After x in the sense, we have to subtract that. So initial time minus x. So that is the reason I have written here. Initial time as t1 minus x. So initial time t1 is taken as t. So t minus x. Is it clear? So from this, you could understand that if anyone tell you reaching simultaneously, both the distances are equal. By simplifying this further, not required now. By simplifying this further, we can calculate the time t. But here not required. Okay. I'm just mean to say what is the concept. Okay, my dear children. We'll go for the next concept now. Very important concept. Suppose there is a body or a particle or your mobile phone, what it may be. It has been dropped from a multi-stored building. In the sense, multi-stored in the sense maybe of 10 floors, 20 floors, 15 floors, what it may be. Multi-stored building has been dropped. So let me assume that the time taken for the body to reach the ground is 3 seconds. Okay? Or let me take it as t seconds. Whatever you want, you can take it. So a body has been dropped from a multi-stored building. Clear? And the time taken for it to reach the ground is t seconds. Let me assume like that. Now, during its path or during its journey, if it has been stopped for t2 seconds, and then again it has been dropped, stopped for some time and again dropped. Two different cases. Stopped for t2 seconds and after some time it has been released or dropped. Okay, so now it reaches the ground. Now my question is that what is the time taken to reach the ground once it has been released? Is it clear? Repeating, my dear children, there is a multi-story building from where a body has been dropped, so no doubt it takes the time some t1 seconds to reach the ground. That is first case. Leave it. Now what I am saying is that suppose if it has been stopped in its journey, you may ask how it has been stopped with it. I say that there is some X person who is putting his hand out of the window and catching whatever the body have thrown. So if it has been caught, what happens? It has been stopped. So this happens for t2 seconds. So after some time, okay, after 5 minutes or 1 hour or 1 day, what it may be, now again he is releasing it. Means again it is dropped. Now again reaches the ground. So from the point of releasing or from the point of dropping to the point of reaching the ground, what was the time taken? This is what is my question. From the point of releasing to the point of reaching the ground, what was the time taken? Is it clear? No. Let me write the question. A body has been dropped from a multi-stored building so that it reaches the ground. In t1 seconds. Like this I say. Okay, my dear children? So there is a multi-stored building like this. There is a multi-stored building like this. Now a body has been dropped. So this is a body. Let this be point A, has been dropped. Dropped means dot lines. So when it has been dropped, as per the given question, body has been dropped. So what I am saying is that the time taken to reach the ground is t1 seconds. So initially, the time taken from this point to this point is t1 seconds. So this is what we are taking. Suppose if the body has been stopped, in its path or in its journey, the body has been stopped in its path or let me say journey after t2 seconds from start. This is what the next question. The body has been stopped, okay, in its path after t2 seconds. So from the start. So this is what is starting position, isn't it? This is what is starting position. So when it is dropped like this, what happens? We are saying that it has been stopped. Two things we have to stress. One is stop and another one is start. So this is the point of starting. Okay. let me say this is the point of stopping. So it has been stopped here. Like this. So here when it has been dropped, it has been stopped at this point. Let me assume that since this point is A, let me assume this point is B. After t2 seconds. So time from A to B is t2 seconds. T2 seconds. So this is what he is saying. Clear? Now, and then it is released. And then it is released after some time. And then it is released again. What did I say? Again. So that it reaches the ground. It reaches the ground after t3 seconds. So when it reaches the ground, we are assuming it as, so this part is nothing but ground. So we assume the time taken from B to C as t3. Okay. So my question is, find t3. So what is this t3? This is what is my question. My dear children, understood? So initially there is a body. If it has been dropped freely, let us assume that the time taken is t1 to reach the ground. Second case is that instead of free journey, suppose if there is some X person who is catching it or stopping its journey after t2 seconds, and then again it has been released. So that the time taken is t3. So what is the relationship between t1, t2 and t3? This is what is the question. But here the major concept is that at this point it has been stopped, again it has been released or released. Released in the sense again it is free fall. Free fall in the sense again the velocity at this particular point is equal to 0. Free falling in the sense again the velocity at that particular point is equal to 0. Since the body is coming down, what I have to say is that acceleration from A to B coming down, no? So it is plus g. And here also since it is coming down, the acceleration from B to C, it is also equal to plus g. Acceleration from B to C, it is also equal to plus g, like this. Okay. Look, we know that the total distance from A to C can be taken as A to B and B to C. Like that I can take. The total distance from A to B can be written as total distance from A to C can be written as A to B plus B to C. This is the way I could write. So at point A, as per the given question, a body has been dropped. Body has been dropped. So at this point, a body has been dropped. Dropped in the sense, as I told you earlier, the velocity at this point is equal to 0. Okay. So as for this formula, distance is ut plus half gt square. This is from A to B. So this is point at A because A is initial point. So this u stands for initial velocity. So initial in the sense at point A only because A is initial point. Okay. So where initial velocity is a point A and the time is from A to B. A to B. I could write like this. Okay, my dear children. Plus again B to C. ut plus half A t square. So B here is initial. So u stands for initial velocity. So I have to take it as initial velocity at point B from B to C journey. Whereas time, that is from B to C. Like this I could write. Is it clear? So it was very clear that the velocity at point A is equal to 0. So this part is 0. 0 and anything is 0. Now, okay, this TF is nothing but T2. So 0 plus half G T2 square plus, whereas again at point B you are saying that, I am saying somewhere, released again, released in the sense again it is dropped. Since it is released at point B, again the velocity is 0. So this is some different case which you have to understand. Normally there must be some velocity at that point. But since you are saying that again it has been released, dropped. Again it has been dropped from that particular instant. So what does it mean? Again the velocity is equal to 0. Okay. So again at point B the velocity is 0 as given in the question. Plus half, right? G, half G, time from B to C. The time from B to C is T3. So let me say that the time from B to C is T3. Like this I'll get. So adding up of both, I'll get half G T2 square plus half G T3 square. Now half G is taken as common, T2 square plus T3 square. This is what I'll get it. Okay. Now what about A to C? A to C also same way. There is nothing, no difference here. So again same formula repeated. That is ut plus half A t square. This is at A is initial point and time taken is A to C. Is it clear? So here also will apply the same formula. But here we could mention earlier. The body has been dropped from point A. So drop means initial velocity is 0. Initial velocity is 0. So the time taken to reach the ground is T1. So here this part is 0. The remaining part is half A. A is nothing but G. And time taken from A to point C is nothing but T1 we have taken. So into T1 square. The same thing coming here. Half G into T1 square. So half cancel, G cancel. So the remaining part is T1 square is equal to T2 square plus T3 square. T1 square equal to T2 square plus T3 square. Okay. So our interest upon is that we have to find out this T3. We have to find out T3. T3 is nothing but time taken from B to C. So what I could do is that just move this side. Just move this T to this side. So it is T1 square minus T2 square is equal to T3 square. You just move this T to other side. Okay. So from this, what is T3? What is T3? So the square will come this side. Therefore, T3 is equal to root over T1 square minus T2 square. T3 is equal to root over T1 square minus T2 square. Okay. So this is what is the time from B to C. Very important concept, my dear children. Have a careful look at this, you will understand. Okay. So look here, at the first point it has been dropped. That is what given in the question. And released again where? Again at point B. So in both the cases, released or dropped or freely fallen, we have to take the velocity at this point is equal to 0. So that is what the only twist in this question. And remaining everything is same as before. Okay. I hope that you will understand this. Thank you.